So today I'm talking about the software development lifecycle and the biggest problem with software development life cycles is estimation. How do you estimate how long things are going to take? Or on the other side, if you know how much time you have, how much work can you get done in that amount of time? So that's the estimation problem. Now, this lecture comes from a friend of mine at Google. He wasn't a close friend, but I became friends with him after he taught this, and I attended his class several times. He had made his career at Google going around the world and teaching teams about the task estimation and how to do it effectively. And I took it and I was so enamored with it. I took it probably twice, 3 times. And then I had my team take it. And then I had, when I was a director, I made every one of my teams reporting to me take it. So, and I sat in many of those. I really enjoyed it. I sat in this for probably 6 or 8 times. So I got a pretty good sense for what it is, the concept is and what it goes for. And so I'm doing this. Now, when he does it, though, he requires that every member of the team plus the product manager all get together and devote 3 full days to this training. So it's 3 days of training, which is, I got a lot of grumbling. I'm going to get behind on my schedule. Oh, well. And that the reason that I made them do it is because it made them much, much, much better at figuring out how long things were going to take and how much they could actually get done. So that's the purpose of this, and that's what this is based on. So it's based on and again, I'm not taking 3 days. I'm trying to get the most important concepts and give them to you in about an hour. So we're going to skim over a lot of stuff and skip a lot of stuff, but at least you get the concepts down. All right. So anyway, so before I tell you, I asked the question, what is the task estimation problem? What is the problem with estimating? I'm going to go through the software development lifecycle. So while I'm doing this, you can be thinking, what is the estimation problem? So let's do that. First of all, in order to build software, what do you have to have? The first thing you have to have.
Computer.
No, you don't even need a computer. Computer's not a correct answer. Maybe your customers need computers, but you don't. What do you need?
An idea?
An idea. Okay, so I'm calling that the business requirements. Basically, the business requirements, in the waterfall model picture I had, it only says requirements. And so there are actually two parts of it. The first it's called the business requirements. And it's basically, who's my target? Who am I selling to? Who do I want this product to be for? What are the major features that they want? And then also, in addition to that, they're going to want to know how much are you willing to spend, or how much am I? Usually this is done by the executive committee. How much are we willing to spend on this? How much revenue do we expect to get back from it? And so you figure out those things and you write up what we call a BRD, or a business requirements document. And then that business requirements document gets passed to the product team, has product managers on it, and the product managers do their part of the requirements, which would be they would take all of this stuff and they would break it down into what they want, what they think the product should look like. Basically what's the broad outline of how it works. What are the features? We call those use cases because the features are usually written as the user can X, the user can Y. So they're called use cases. And then they would figure out okay, well, how many pages do we want? How do we want the flow to be? At least approximately 5 pages. We go from here to here. For example, in an e-com site, the business may say, we want to sell our stuff online. And then the product team says, okay, we need an e-com site. We need a catalog page. We need a details product page. We need a shopping cart page, and so on. And they'll figure that out and they'll say, okay, From the catalog, you should be able to get to the details. You should be able to get to the shopping cart, and things like that. And then they'll often put together simple wireframes that are not much more than hand-drawn diagrams of how they want the pages to look. Okay, I'm going to want a rectangle here where I'm going to put the catalog, and I'll just put the word catalog on it. And then a header. We want a header with a shopping cart in it and that kind of stuff. All right. So that, and then they produce what we call a product requirements document, or a PRD. And then once they're done with that, then they hand it off to the UX design team. The UX design team, I explained last time, it used to be called UI design. So you might hear it called UI design. And then the UI designers were mostly, how do you get the details on the page? How do you get what colors do you use? What interactions do you want? What are the buttons going to look like? How do the do we want drop downs, pop-ups, dialogues, etc. Little things like that. And they got kind of tired they didn't think that their job was important enough. So they got in a bit of a tussle with the product managers and tried to take over some of their work. And in well-known approaches to winning battles in these days, they renamed themselves and they called themselves user experience designers. So they felt like they should own the entire user experience. And so they were able to, in some places, they're able to wrest a bit of responsibility for some of the wireframing and flow and stuff over into the UX design. So it will kind of depend on where you are as to where these fall. What I've shown here is how it was at Google, where the product manager did most of the flow. But anyway, the UX designer fleshes out the details. And so they'll get pixel perfect screenshots of what they want each of the pages to look like, how they want them to interact. They usually will be like in Figma or something like that. Sometimes they'll even produce HTML and CSS, and they'll show you, okay, here is exactly what the product catalog should look like. It should be 4 across and 3 down in a normal size page, and then this is how it should behave when you resize. Here's how it looks on mobile. I'll get all the interaction details. When I click on, I want in the catalog, I want a little add to cart button in case they want to buy right there. Things like that. They'll figure out all the final details, get all the graphics down, get the artwork done, and all of this. And then when they're done with that, then it's finally time for, oh my goodness, I just realized that the waterfall model there only did 1 bullet per design, but there's actually 2 design steps. One is the UI design, the other is the technical design. So once you've got your Figma or something like that, you can actually now look at it and think as a developer, okay, what kind of things do I need to build? I'm going to need, if it's a shopping cart, I need a front end, I need a back end, I need a database. I want to do the front end in React. Because XYZ, I'm going to do the back end in, like if it's us, Node and Express, with the database that we're all familiar with. We'll use Postgres. And so anyway, they just kind of make those decisions. They'll figure out, okay, well, I'm going to have a front end team and a back end team working on these things. I'm going to break the front end into these pages. The back end, I'll have these endpoints, and they'll do all of that kind of stuff. They'll do their DB database schema, figure all that out, and so on. And so we produce what's called a design doc. I'm not sure why it's not called a TDD, technical design doc, but I actually have never seen that. Maybe that's because I'm an engineer, but we always call them design docs at Google. I don't know if other companies might call them something different. But anyway, so we have a design doc that has all the technical design in it. It's usually, 4 or 5 pages long. The PRD might be 15, 20 pages long. And so, it just lays out the technical design. And finally, once we have all of the design work, then finally we get to go into development. So now we do our development. We write the code, we do our unit tests, we deploy the code, push the code into the repo, and then this takes a while to get all the code finally written. And then once the code's written, it gets tested. Now, often in the testing, I put QA, quality assurance, that's what it frequently is called. And the testing usually means I find bugs, it goes back to the development team fixes them, and then so on and so on. Okay. And then once we're done testing, we're not quite finished yet. We still have to deploy it. So then we go do our deployment where we push it up to our production site, which nowadays is usually a cloud system. Okay. So that's the software development lifecycle. There are a number of different ways to organize how this happens and decide how the team is going to execute on it. But pretty much every one of these steps is required for every single software project. You can't really build software without these things being done. It might be the same person for a smaller project doing some of them, but they all have to be done. You have to know all these different parts or you just can't write and ship software. Okay. Any questions on the software development lifecycle? Okay, well, let me talk about waterfall. So the waterfall that I have up there, you'll see I kind of drew on the board. When I drew it, I did each one a little bit lower than the one before it. And I did that on purpose. And that's because I wanted to represent a waterfall. And that's actually how originally software was done. The execs would write up their BRD, hand it to the product team. The product team would do their PRD, they'd hand it off to the UX design, and these guys would go out and worry about and start doing the product design for a different project and just, throw it over the wall, walk away. The UI designers, UX designers would do their design. When they're done, they throw it over the wall, walk away, start working on something else, and then so on. These are usually architects. At least in the old days, they were architects. I don't think that exists anymore for good reasons, thank goodness. So then we have our technical design, and then when they're done, they throw it over the wall to the development teams, and they walk away, work on something else. Then the development team does their work. Usually they're working pretty closely with QA because there's a lot of back and forth in here. And when they're finally done, they throw it over to the deployment team and they walk away. So this is the waterfall model where it's like water falling down a hill, and waterfalls don't go back uphill. So that actually was one of the biggest problems here. For example, if I'm in the development team and I'm writing the code and I think, oh my goodness, they really want me to do that. That's going to take 3 months. But if I were to just make this small change to the to the requirements or the design, I could get it done in a week. And so how do I get approval to do that? Because water doesn't flow uphill. It's very hard. And so you have to work your way up until finally you can get somebody who will agree to spend time with you to talk about your change. And maybe it goes all the way up to here. They approve it. Then it has to go back to here and back to here and back to here. And finally, okay, yes, you're able to do it. So frequently in my life, I would sit there and say, maybe not 3 months. I'd say this is going to take a month. If I change it slightly, it'll take half a week, 3 or 4 days. But it's going to take me 2 months to get through the process. And by the time I get through the process, I'll have lost all the time. So I'll just put the work in and do it the hard way. And oh well, I hope they like it, And so it was very, very challenging. That was one of the big challenges with the waterfall model. But one nice advantage of it was, in theory, let's talk about estimation. How long is it going to take? Once the execs hand it off, how long is it going to take? Well, in theory, we know, or they can calculate, they can figure it out. Maybe they'll say, well, it'll take a couple of months for the product design. Once they have that, they can look at that, and then we can start saying, okay, now we know roughly what complexity it is. So we know about how long this is going to take, and this and this and this, and we can kind of sketch it out and say, okay, good. That means we're just starting this effort now. I know I'm going to have it in 1.5 years. And so I'm going to start getting all of my marketing and everything lined up so that in a year and a half when we ship, we're going to be ready to just have a big marketing splash and make it. So in theory, the estimation is very easy because you know how much work you have. When the waterfall flows down to you, you know how much work you've got exactly because you've been given a perfect spec, and then off you go. So you can estimate it. Now, that was in theory. In practice, when that waterfall hits you, it usually hits you pretty hard, and there are lots of problems with it. And you discover that they didn't actually design the spec out everything that you need. Like the designer forgot to tell you what happens when you click on that button and an error happens, or if you hit cancel or things like that. So and then there's all these issues, and it's very, very hard to get these types of issues resolved because the people you're working with are gone and working on something else. So that's the hassle that we had. And so even though in theory you could estimate how long it was going to take, it was very, very common for the actual total time to equal twice the predicted time. So these execs say, okay, year and a half, we're going to have our marketing push. Then they get about a year into it and they discover that it's not going to be a year and a half from here. It's going to be 3 years. And now they've got another 2-year wait. I actually was consulting after I left Google. I consulted for a team that did a waterfall model. They thought it was agile, but it was really waterfall. And I sat in a meeting. When I first got there, I was told this is a 1.5-year project. And 2 weeks after I joined the team, they had another meeting where they did another estimation, and they said, no, it's really a 3-year project.
Oh, double.
And I doubled it right there. And that was even before we had gotten seriously into the development. So who knows what it would have gone from there. And then I looked at the project and I looked at all of my experience and said, you know what? This isn't a 3-year project. It's a 3-month project. And I talked to the other engineers, and they said, at least the experienced one says, yeah, I think that's I was thinking about that same thing. 3 months, 6 months. Yep. So we said, okay, how do we fix it? And they didn't want to go to the product manager and tell them that their estimates were way off because they said they'll never give us approval to get it done in 3 months. Said, what kind of a company is this? So they won't let you get it done 3 years early. So anyway, it was interesting. We actually ended up shipping it in 6 months. So I was pretty happy with how things went, but after I pushed hard. But anyway, that's kind of the problem that happens with the waterfall model. You'd think that estimation is simple because we know everything up front, but there are too many unknowns, too many things happening that you're not aware of. You usually don't have a good enough sense for how long it takes to get things done. You have interruptions like meetings. This is the same company I went to that had 12 hours a week in meetings. And that was one of the reasons that their estimates were so bad and so on. Okay, so anyway, so the waterfall model was very, very challenging and people were trying to figure out how to do it better. So I think it was the 1990s, it's probably in my slides, but I won't look at them. In the 1990s, some people came out with what they called XP, stands for Extreme Programming. And it was just a complete rethink of this model of how to do development. And we evolved that. We don't call it XP anymore. Instead, we have various flavors on it. We call it Agile. So the Agile model, I like to say that the Agile model still has you have to have all of these things in it. But instead of doing it in a waterfall, we just do it all at once. It's like a whirlpool. And we just do it all at once. And so that's really what happens is it becomes very, very iterative. You'll start here with your cake. This is still handed to you. And then you'll put a team together of the product manager, the UI designer, and the tech lead. And those three form the the leadership for this project, and they're now given responsibility for building the project. They don't do the waterfall thing. Instead, they just kind of mix it all up, do it all at once. So they'll say, okay, well, we're going to build an e-com site. We know we're going to need a catalog page. Let's focus on the catalog page and forget the rest of it right now. And so they'll focus down on the catalog, and they'll try to get the catalog thing designed, and these three will sit in meetings, and now the developer could say, that's a cool design, but you realize that's going to take me 3 months to build. And then they have a discussion. Is it worth 3 months? It's so cool, it's worth the 3 months, or can we find a better way? And there will be all the give and take, and they'll figure that out right there. And then they develop it. They usually they'll do the development in sprints. And so the sprint is typically 2 weeks long, varies from company to company, but they're typically 2 weeks. And what they'll say is, okay, we're working on the catalog page. For this upcoming 2 weeks, let's figure out how to at least get the products showing on the screen that have been read from the database. That's our goal for the next 2 weeks. And they'll sit down and figure out how to do just that much of it. Get it all done. Pretty rough in all the places, because it's just kind of it's not thoroughly spec'd out, not thoroughly implemented. A lot of loose ends and shortcuts have been taken. But then after 2 weeks, they'll come back together and they have what's called a sell-off meeting, and they will meet together. The development team will meet with this 3-person leadership team. They'll go through everything that they did. They'll be able to say, oh, we had trouble with the database issues because of this. Oh, okay, we need to go back and rethink our database design. We don't like the way this interaction works, or we're happy with it, we'll stick with it. And then they say, okay, for the next 2 weeks, we're going to fix these problems, and then start looking at the details page, things like that. So this is how it goes. A lot of iteration, just thinking about things, do a little bit, try it out, see what it looks like, play with it, click around, make sure you like it, fix what you don't like, add tasks to the list to fix the things you don't like, and so on. And then it just iterates and iterates and iterates and iterates. So this is the way that most software development is developed nowadays, is with some type of an agile process, where it's just all this iteration, sprints and sell-off meetings, and then you have daily stand-ups where you get together and just talk. Everybody just says, this is what I did yesterday, this is what I'm doing today, these are my blockers. Okay, and you just go around the room, do all of that. I ask my students, why do you think they call it stand-ups? Because you do stand up. Why do they make you stand up? To keep it short. Okay, so and they should be short. That again, this company that thought they were doing agile was really doing waterfall. Our stand-ups would go an hour to an hour and a half, and it was excruciating. They should be 5 minutes. Okay, so in a well-run project, they're very quick stand-ups. Okay, so anyway, now let's get into estimation. Finally. So what's the problem with estimation in the agile process? I went through what it is in the waterfall. What's the problem with estimation in the agile process? I'm going to focus just on agile from here on out.
It's hard to estimate because it's not divided like the waterfall. The vision has to be easy to estimate.
Okay, so it's not divided up so much. It's just kind of all jumbled together. So it's harder to say, well, okay, the design's going to take a month and so on. It's hard to do that. Anything else?
I mean, like about the unknown. I mean, it'll still be there, right? Like something that you don't know. How would you estimate the time for that?
Exactly. And since you don't know everything yet, everything is unknown. There's only a tiny bit that's known. And then 2 weeks from now, when your sprint's done, you might discover that what we thought we knew, we didn't really know, because we don't like how it worked out. So it's all unknowns. And if you don't know, you can't estimate it. So that's really when it comes down to it, that is the biggest problem with an agile development system. It is estimating how long it's going to take, because you're iterating, you don't really know. I can't say, oh, we're going to be done with development in 3 months. I don't know, because I don't know exactly what it is we're building. I can say, I've done a project like this before, and that took us 3 months, so maybe it'll be 3 months. But it's very hard to sit there and say, yes, we should start our marketing efforts right now to get them ready because we're going to ship in 3 months. I can't say that, because I don't know. I don't know what we're building yet. So that's the biggest problem with agile development, is that estimation problem. And that is why this guy went around from team to team to team all around Google, all over the world, teaching them how to do estimations in an agile development process. So I'm going to talk about that a little bit. Just kind of go through some of the things to do for it. So we talked about it's hard because you don't really know what's going on, but it's also hard because we don't account for the ramp up time, how long it's going to take to get everybody on board and get going. The unknowns, we don't know what the unknowns are. There's unexpected things that come up always. Oh, gee, I didn't think that was going to be that hard. And it looked easy. And it turned out the package that I was going to use isn't going to work. Oh, now what? Okay, we have interruptions all over the place. We fail to take into account how long they're going to take. Like nobody would have guessed we were losing 12 hours a week to meetings and per engineer. And so, you know, we just don't think about that. We don't think about, oh, we got interrupted because we have to go back to an old project and fix some bugs. You know, that happens a lot too. So there's all these interruptions. There's regular, you know, meetings and coordination. And then, oh no, you guys saw the last one. Those who are online. The one that I like the most, that is most fun, is programmer productivity. So if I estimate how long it's going to take a task, and I say, yes, that's a 3-day task. Well, how long do you think it will take you? How long do you think it will take my friend? How long do you think it will take someone else? So our productivity varies tremendously from developer to developer, not just because of experience, though that has a huge impact on it, but just because we're different. I worked with a very, very experienced developer who wrote excellent code, but man, he was slow. Okay. And, you know, we just, okay, if he did the estimates, he would have estimated about 3 times longer than the rest of us did. And if we did the estimates and he did the work, it would take 3 times longer than we estimated. So, you know, it's pretty tough. So anyway, AT&T Bell Labs, in the 1960s, they were the premier research organization in the US, and they had a big software development team. And they wanted to ask this question: how do we measure programmer productivity? It's very, very hard to measure programmer productivity. Lines of code is a bad choice because, as we talked about before, sometimes writing less code is better and more productive. But it's a measure. And anyway, so they came up with 6 or 8 different measurements, and they ran them all and did this big study. And they said every single one of the measurements that we used came up with the same outcome. And that was, there's a huge difference in productivity between the least productive and the most productive developers, even at the same level. Anyone want to guess what that difference was? The fastest one is 10% faster, 50% faster, twice as fast.
50%.
50%, 6 times faster.
It depends on about what it's doing.
No, it's just you're given a task, and we say, how long is it going to take you to do it? How long is it going to take me to do it? So we do that comparison. Okay. So the answer that they came up with is that the difference between the fastest person doing the same task, the same work, it would take the fastest person 20 times, the slowest person 20 times faster than the fastest person. So in other words, it's incredible. In other words, I can give it to one engineer. It takes him a month. I can give it to the fastest engineer, they'll be done in a day. I mean, it's incredible.
Why is
The
that?
difference in productivity. Don't know, just human nature, I guess. I don't know why this guy I told you about was so slow. He just had to think about things, be more methodical and more careful. His code was great, but it just took him a long time. Okay. All right. So all of these things make it extremely hard to estimate how long things are going to take. Yes.
And back in like the 1980s, and how was it viewed if a programmer was slow or fast? Was it a big
Oh yeah, it would impact
impact?
your promotions,
Oh.
your salary, so on. In the 60s, they didn't pay out in stock, so it wouldn't affect your stock. The way that we ended up with developers usually getting paid with stock is a fun, interesting story. I'll have to tell some other time.
Oh, okay.
So I'm going to erase part of this and start writing on the board. And so what I'm going to talk about is how do you estimate how long things are going to take? That's what I'm going to focus on right now. So first of all, we need some way to measure effort. So we're going to measure it in hours, days, lines of code.
I would measure it in lines of clean functioning code.
Okay. Turns out that I can produce clean functioning code faster than the other guy by a factor of 20. Well, I'm not in the 20x guy. I'm not a 20x guy. I may be a 5 or 6x guy, but there are a lot faster than me. But anyway, so that doesn't work. Lines of code doesn't work. Time doesn't work because again, it'll take me a day and it'll take the other guy 10 days, right? So what do? We punt. And we use what we call points. So a point is just a magical number made up. It has no meaning except for some mathematical relationships. If I have a 1 point, if I say this task A is 1 point, and I just arbitrarily say that's a 1 point task. Then I have task, and then I say task B is a 2 point task. Then task B should take about twice as much time as task A. Okay. So that relationship needs to hold. So then if I do a 4 point task, it should take about twice as much time as task B. Okay. And then, or 4 times as long as task A. So if task A took 3 days, then task B would take 6 days, and task C would take 12 days. So that's the only thing that's important on points, is that they honor this relationship. Okay. And they're just assigned randomly, or not randomly, but they're assigned, there's no real meaning. 1 point could mean 1 day to you, it could mean 1 hour to me, it could mean 1 week to someone else. Okay, it really has no relationship to time. It's just an arbitrary number that is assigned to a task, and they always follow this relationship. Okay. Now there's another thing that we do with points, and that is for reasons historical, I think it was just kind of fun, as we usually only we only assign points using Fibonacci numbers. Who knows what the Fibonacci sequence is? Oh, is it one? I think it's. Oh, I think I spelled it right. Okay, Fibonacci. What's the Fibonacci series?
3.4.
To calculate the Fibonacci, it's a series, so you need several numbers. To calculate the Fibonacci series, to get the next number in the series, you take the prior 2 numbers and you add them together. And you usually start with 1, 1. So we say 1, 1. So if you add those 2 together, what's the next one going to be?
2.
2. What's the next one going to be?
3.
3. Then
5.
5,
8.
8, 13, and so on. Okay. These are the Fibonacci numbers. And Fibonacci numbers show up a lot of places in nature. I'm not quite sure why they were chosen for task estimation, but it's just what we do. It's kind of fun, but it does have the nice property that as the numbers get bigger, they get farther apart. And that's true in general. If there's a big task, it's much harder to predict precisely when it's going to happen than if you have a small task. Like, okay, write this function. I can have a fairly good idea how quickly I can write that function. But if I say build an e-com site, I'm more likely to be off by a bit. And so as to how long it's really going to take. So as the numbers get bigger, they get farther apart, which is good. Okay, so this 4-point task, we actually would never assign 4 to anything because it's not a Fibonacci number. Instead, we would assign what? 3.
5.
5. So this comes up, and the rule is if you have a number that's not a Fibonacci number, it's in between here, you always go to the next larger one. Why do you think we do that? Because it's better to estimate high than low.
Worst case scenario.
Because usually things do take longer than you think, and you'd rather say it's going to take a week and then take 5 days. So you'd rather, I guess, 5 days is a week in work days. So you'd rather say it's going to take 5 days and then have it only take 4 than the other way around.
Right.
Say it's going to take 3 and then it takes 4, then it's a problem. So you always go bigger. Okay, so now we got these points. So here's what we do. This is just the arbitrary way that we measure things. So what we do is we first of all we get what we call the baseline tasks. So we get baseline tasks. So here we are. I've got my tasks through the baseline. What my friend would do when he had a team take his class is he would say, I want you to go through all of your task list, and I want you to come out with 2 examples of a small task, a medium task, and a large task. And I want the medium task to be about twice as much as the small task, and I want the large task to be about twice as much as hard as the medium task. And we'd have 2 examples of each. And then I said, okay, once they came up with their tasks like this, he would say, okay, the small task is 1 point, the medium task is 2 points, the large task is 5 points. So they followed this ratio. Okay, so here's my baseline tasks. So now it's a fairly straightforward effort to figure out how long something's going to take. These are my baseline. So now if I have my actual tasks, let me say they're X, Y, Z, W, T arbitrarily. Okay, so I just look at each task. I say X, how does it compare to my baseline tasks? Is it like this one or like that one? And you just kind of figure out which one it is most similar to. So we as humans are very, very bad at estimating how long things are going to take. Have any of you ever had a contractor come to your house and do work on your house? Did they get done in the time they said? Some do, some don't. Most likely they don't. It's not just software developers who are bad at estimating. It's the human species that is bad at estimating how long things are going to take. And we run into all those same problems: unknowns, interruptions, unexpected things, and so on. And so, so if we sit down and try to estimate how long something is going to take, we're going to fail. So what we've done here is we've changed the estimation problem, estimating how long something is going to take. We've converted it into a comparison problem. Okay, we are very good as humans at comparing. I can tell you this one is very similar to that one. They may be completely different technologies, product, everything else, but I can look at it and say that's probably about the same as this one. And we're good at that. So what you'll do is you'll sit the team down and you'll go through all these tasks and you'll vote. Everybody votes. Usually you'll do it. They have cards for this. Call them, I forget what they call it, agile poker or something like that. but it's just cards that have the Fibonacci numbers on them. And so you'll say, okay, task X, we'll discuss what task X is. Then we'll say a 1, 2, 3 vote, and everybody will hold up a card that says how many points they think that task should have. And if you're about the same, then it's easy. If there's a little bit of discrepancy, you take the highest number because you always want to overestimate instead of underestimate. If there's some real outliers, like one person says it's a 1 and everybody else says it's a 5, then you're going to ask, okay, the 1, why? Why is it this way? And they'll have a discussion. And once you have your discussion, maybe they'll talk everybody else into changing. Maybe everybody else will talk that person into changing, and you vote again. And you keep doing that until you get something that is reasonably close, and then the Scrum Master, they call him, will figure out what to assign. So here we go. So now we say, okay, this is a 2, this is a 2, this is a 1, this is a 5, and this is a 1. So we've now got we've done this task estimation. Okay. All right. So now it's easy. We've done all the hard work. Now it's easy. Well, not quite yet. Well, I can tell you to do all of these is how many points? This is a 5, 7, 9, 10, 11. This is an 11-point effort. 11 is not a Fibonacci number, but 13 is. So I'd say, okay, this is a 13-point project. Okay. So that's what I would say. This is 13 points. And okay, cool. 13 points. How long is it going to take?
13 months.
Depends on how long a point is, doesn't it?
Yes.
How do you figure out how long a point is?
Does somebody decide that?
Somebody does.
The main.
For each person and each team. Usually you do it for the team as a whole. And the way you do it is you keep track. You go through this process. You say, we think that these are 2 point, 1 point, 5 point, and 1 point tasks. You do the work. You record what work was done, how long it actually took, and then you start doing some math. You say, okay, this 13-point project, this 2-point project took 2 days, 3 days, a day, a week and a half, a day, and so you kind of get a sense for, okay, then a point is close to a day. Maybe it's a day and a half. You just look at your logs and you do it. The longer you do it, month after month after month after month, you have all this information. Your points to time calculation gets better and better and better. Okay. So that's basically what you're going to do. So we will come up with days per point. And suppose we have 2 days per point. So our 13-point task will take 26 days. Okay, about a month. So that's what you do. That's how you do that. It requires you to keep a track, to keep a log, and use that. Now, there's a very important thing when you're keeping this log. What do you keep track of? How do you keep track of your time?
By functionality, if the features are functional.
Well, no, you just do the work. So I know when I started, I know when I was done. What do I record?
The workflow.
How many hours I worked on it? Well, let's see. I worked 3 hours this morning, 2 hours this afternoon. It was a 1-point task.
I don't think
I was done in 5 hours.
I think that's realistic.
What should you do instead then? So what we've discovered is that you need to do your logging and log tracking. You have to track calendar time. This is critical.
Yeah.
This is critical, absolutely crucial to your success. So I may have worked on it. Maybe I had a meeting today, so I only got to spend 3 hours in development instead of 5. And tomorrow I got all 5 hours or 8 hours, whatever it was. And so it took me, I only worked on it for 6 hours, but it took 2 days, 2 calendar days. So I write down in my log, this 1 point task took 2 days. You track calendar time. Why do you think we want to track calendar time?
Because the time for a developer that takes to focus and get in the flow varies, so it's better
Yes.
just tracking days.
Yep. And the cost of interruptions varies. It's kind of random. Or if it's meetings, they probably occur on a reasonably regular schedule.
Mhm.
So you just, instead of trying to guess and say, okay, let's see, this 1 point task is going to take 6 hours of development. I think we can get 6 hours done in a day and a half, or in half a day, or whatever. It's too much guesswork. It doesn't account into all the interruptions that will happen. You say it's going to take a day and a half, and then you discover that, whoops, we had meetings today. So it really took 2 days. You don't, so you just let all that, you just wash that all away, and you track calendar time. So it took 2 days. I was working on it. I started on Monday. I finished at the end of Tuesday. It's 2 days. Doesn't matter what I was doing those time. Doesn't matter if I was spending all my time playing games, goofing off, surfing the web, doing research, going to meetings. It took me 2 days, and that's what you record. Okay. And by recording and tracking your calendar time, then you can get it just lets all of the interruptions and unknowns and everything else that happens just kind of, get washed out, comes out in the wash. We just know that this, a 1 point task takes roughly 2 days, period. Okay. So there you go. And that's what you do. Now, what about the problem where my 5-day task might take me 2 days and someone else 5 days? So you just count it up as a team. How much are we as a team able to get done? So you usually do it as a team, but you should keep track of by yourself as to what things take. So this is why in our stand-ups, I make you tell me not what you're hoping to get done today. I want you to tell me, this is what I think I can get done. And then tomorrow, when you tell me what you actually got done, we'll compare it to what you thought you would get done. I'm doing this to help you get a sense for how long it takes you to get tasks done. You need to gain that sense. You need to know how much you can get done in a typical day, or 2 days, or so on. It's very important for you to gain that sense to be successful as a developer, because you'll be asked all the time, here's a task, how long do you think it'll take? I almost guarantee every time you're given a task, you'll be asked how long you think it'll take. Or maybe if you're just starting, you'll say you have 2 days. But you need to get that sense. So when they say, oh yes, I can take that task, that'll take me 3 days. Or what, I'm supposed to get that task done this sprint and it's 2 weeks long. Sorry, that's too big for me. I'm going to need help. So you need to gain that sense for how long things take. So that's why when we do our stand-ups, I make you tell me what you think you're going to get done. And then the next day we compare it to what you actually got done. And I don't care if there are interruptions or what it was, we're tracking calendar time and so on. I'm just trying to help you get a sense. I don't care if you got done what you wanted to or not. That's not for me. I care if you're making progress, but the real purpose of that is for you to gain a sense for how long it takes to get things done. Okay. All right. So that's the main thing. Now it's very simple. We have a task. We just add them all up. So suppose we're doing a sprint. We know that our team can get 10 points done per sprint. So we've got all these tasks. Whoops, this is going to take a little bit longer than a sprint. So we know that we can get this thing done in a sprint and a half. Okay, so that's how we use it that way. Now there's another way that we can use it. Is the other side is we've added up all of our tasks. It comes to 13. We have a sprint. We know we can normally get 8 points done in a sprint. So now we just say, well, okay, which tasks are we going to do? 5, 6, 7, 8. I guess those ones, or 2, 4, 5, 6. We'll do those ones and leave this one for the later or something.
Oh.
So you can just kind of pick out the tasks and start saying, okay, We got 8 points we can get done this sprint. Let's do this one, that one, and that one, and that one. Okay. And then you've got your work assignment done for the coming sprint. So that's the other side that it's useful.
That's good.
Okay. So that's the estimation problem. And we're done, except for one fun little thing is this one isn't really that critical, but it's just kind of fun. So I spent a few minutes telling you. And that is, suppose you have 8 points you can get done in this sprint. Which ones do you take? Do I take those ones, add up to 8? Do I take those ones? Do I take those 2 and that one, those 2 and that one, so on? How do I pick out my 8 points?
You pick the core.
Core. Do you remember what we talked about? Well, first of all, you have to make sure you get all of your blockers out of the way. I can't do task X until Z is finished. So obviously I need to pick Z before I pick X, that kind of thing. All right.
Okay.
So you do that. That's one of the first things that you do to get all the blockers out of the way. But let's assume that we've gotten all the blockers out of the way. Now we're trying to pick them. Would you rather do the 5-point task first or the 1-point task first?
1 point.
Or the 2 points? Okay. How do you decide?
Because they all depend upon each other. That's the
No,
problem.
they don't depend on each other. We've already gotten rid of all that. These are
Okay,
all
okay.
independent tasks. Okay. So what are you going to do? Well, it'd be kind of fun to get a lot of things done quickly. And then, so we do the 1-point ones, but then we get to the end and we got this big, huge task that we have to get finished and we're slogging through it. Maybe it'd be fun to get the big one done first. Or I talked about before the other day about doing our challenges first. So maybe this one's the most challenging. Let's do it first. So there are all these things that come into play. So there's a little trick that my friend taught us at Google. He says, okay, so you do this. Here's the task. Here's the points. And then the next thing you do is you figure out the benefit. The cost or the benefit. I guess it's either way. What did I say in here? I said cost. Now that I'm thinking about it, it might actually have been the benefit. I probably should go back and change that. I'm going to do that. So I'm going to put the benefit, the dollars. So this is the dollars. So what you get your product manager to do is say is if we build X, it will deliver this much dollars to our company's bottom line. Okay, so this task is worth this many dollars. This task is worth that many dollars. This task is worth that many. Okay. All right. So it's it can be challenging. Sometimes it's hard for them, but if nothing else, you can say, well, this is a cleanup task. And if I can do the cleanup, then I can get things done faster in the future. And so you figure out how much that's worth, so on. So anyway, you just go and you'll estimate the dollars. And let's just put, 10, 8, 5, 20, 6. Just arbitrary. I just picked them out of the hat. Okay, this one's bigger, but it's also higher value. Okay, so now how do you decide which one to do? Do the most valuable ones first?
Yeah.
Well, that was going to take a long time. So I don't know. That's not obvious to me.
You can do multiple smaller ones and
Okay.
have the same amount of money.
Divide and conquer.
Divide and conquer. Well, nice. I'm just going to divide. Okay. So what you do is you take the ratio. Dollars over points. Okay, so 10 over 2 is 5, 8 over 2 is 4, 5 over 1 is 5, 20 over 5 is 4, 6 over 1 is 6. Now, the one with the highest ratio is the one you take first. And if you actually do a little calculus, you can prove that using this technique actually delivers the most value to the company the quickest.
Cool.
Okay, so which one do I do first? This one. 1. Okay, then it would be a tie between these two. and then a tie between these two. And maybe if I change my numbers a little bit, just for illustration purposes, let me make this an 11 and that a 9. So this is going to be 5.5. This is going to be 4.5. This is a 5. That's a 4. So now you do this one first, then this one, then this one, then this one, and this one. Okay. So that's how you pick them up. And it's kind of fun. I never had any teams that I had them try to do this, but it was too challenging. So I've never seen them actually use that, but it's kind of a cool one to go. It certainly is a good way to think about it. So what happens here is the hard, valuable but hard one, look, it goes down to the bottom of the list because it's too hard. It takes too long to deliver value. The easy but valuable one bubbles up to the top. Cool, I get this done and it gets a lot of value. Okay, all right. So anyway, okay, that is my lecture on estimations. It's important. The most important thing for you to learn, to remember from this, you'll be doing Agile, most likely. You'll probably be doing points, because all the Agile systems use points. You need to understand what they do and what they represent. Remember that your goal is not to guess how long this will take, but to turn it into a comparison problem. Do this in your own mind. Track how long it takes you to do things, to do tasks, so you can get a sense. Right now, you're just kind of still don't know enough to do that very well, but as you move forward and track how long it takes you to do things, oh, this is a 2-point task, how long does it take? And track calendar time and just keep a log so that you get a good sense for how long it takes you to do things. Okay?
Okay.
All right, any questions at all from anyone? All right. We'll see you tomorrow. Anyone